Hi everyone, and welcome to today's session after a long month. So today we're going to go through the latest features in TaskGen, and the latest features are basically using conversation as a way to guide the agent to take actions and reply the user. So this is more like a personal assistant, like maybe JARVIS or what. You talk to the agent and the agent decides what tasks it needs to do and then replies you after the task is complete. All right. So this makes it quite similar to the existing framework like AutoGen through AI that uses conversation. The difference is that fundamentally we are not using conversation to make the actions and so on. We are actually using TaskGen task following. So like for example, what do I mean by that? If you just look at the TaskGen repo, task following is something like this. You have a certain task that the agent is assigned, like give me 5 words rhyming with cool and make a 4-sentence poem rhyming with them. And this is interpreted at the back end into subtasks. Any subtask will be executed by a function and so on. And in the end, you can just reply the user like that. So this at the base level, TaskGen is designed so that it interprets tasks and runs by tasks rather than like talk to the user and so on. So this talking interface is more of like a wrapper above it so that it gives a more like personal touch. And I think it's actually also more efficient than using conversation-based methods to do the task, which is what is done in most agentic frameworks. Okay, so let's just go into like, so I'm just repeating this again for like those who are going to be new to TaskGen. Like you can just create your own custom LM, and this custom LM basically has this specific like system prompt, user prompt, and you just put in your own client over here. So I already ran this cell. I'm not going to run this again. This basically just returns a response, and this response is based on like what the LM has given you. So this can be an open source LM as well. So I give you some examples here, like you can use Claude, just change these keys to your own secret keys, and Azure OpenAI also, if you have some, you can do it here. So you can do like Claude. I tested with Claude Haiku, it kind of works. Llama, I tested with Llama 8B, also not too bad. Of course, you can use the larger models. Now there's Claude 3.5 also, you can use those. So yeah, these are just some examples of how to, like, you just need to take in the system prompt, the user prompt, you can output whatever the model outputs as your response. And so it's very flexible. You can use like any open source LM as well. Okay. As long as the LM is capable of doing JSON formatting, it's good to use. All right, so let me just roughly go through the conversation class. So this is ConversableAgent. This is also in TaskGen itself. So I've created a new conversation.py, and inside here is just a ConversableAgent. This wraps over agent to make it a conversation. And like, let me just go through based on this notebook. So based on this conversable agent, you can put in your original agent. You put in this thing called the persistent memory, which is basically a dictionary of keys and values of whatever you want this conversable agent to track for you through the conversation. So you can track like user emotions, you can track maybe like what the user has done. You can specify like you want it to be an array form, you want it to be a non-array form. So there's some differences here compared to what I did before for conversation. I actually make this a bit more flexible in terms of how you define the type of how you want to track this persistent memory through the conversation. Okay. Of course, you can also track like at every point of conversation, what is the state of the user's emotion and so on. You can do that. And in order to do that, you need to store the memory yourself. Okay, but this class has this persistent memory that tracks the current state of the user at each point of conversation so as to do some value add to the response. All right, you can also define like how you want to call the person. So this helps with the LM understanding who is talking to. So by default is user. If you interface with a game like escape room, you can call this person a game, right? If you interface it with like some other environment, like some robotic environment, you can call it the environment, all right? So number of past conversation is basically how many conversations you want to store in this agent. How many like past conversations. So it's like if the agent replies the user, that's one conversation. User replies agent, that's the second conversation. By default, we store 5. This helps to store some text for how much to reply. We have verbose also, and verbose is basically whether or not to print out the inner thoughts of the agent. Okay, by default, this is true. So we initialize the agent, we store the variables. We define 3 new shared variables. Okay, so this is something that I like to highlight in this session also. Shared variables are like the state. It's like a scratch pad for the agent. I mean, if you think of it in LangGraph terms, it's basically to store a state in the agent so that we can reference it later on for our processing needs. So the shared variables will be able to be used by any of the functions the agent has. And you can also use these shared variables to, do some processing of your agent. So we have this shared variables, persistent memory, shared variables, conversation, shared variables, summary of conversation, 3 new shared variables that we add when we initialize this agent, conversable agent class. So this tracks the memory at each state of the conversation. This tracks the entire conversation itself. And this summary of conversation tracks the summarized conversation. Okay, so you can already see there's already multiple forms of abstraction for this memory for this agent. And this helps to increase the performance, right? So how does the agent work? All right, the agent works by first, okay, every time you want to talk to the agent, you just call the chat function. And the chat function, firstly, will find out whether or not there's any actions that the agent can take. So by actions, I don't mean use LM. Okay, because use LM, you could just get the agent to reply the user. You don't have to call use LM directly. And also we don't want to call end task because that's not really a function. That's like ending the task. So if let's say you have other functions like add number to list, check whether, those kind of actions, if you have any, we will call the baseline TaskGen, right, to decide what actions to take. Okay, and basically use these actions to help to reply the user's query. Okay, so note here that I have delinked the use LM action to the other actions, and that's intentional. It's because we don't want the LM to hallucinate the actions. Because if you give it the large language model to reply with, it might just say, I have done the action, okay, when it actually hasn't done yet. So I want all the actions to be delinked from the LM part. Right, so after we have done the actions, we can then reply the user. And we basically just reply the user by saying, hey, respond to this latest input by the user. Okay, use past conversation, persistent memory, and subtask completed as context. When replying, do not hallucinate actions in subtask completed. So I do not want it to say actions that it has not done before. Okay, so do note this is not a foolproof way of preventing hallucination. If you use a lousier model, I mean, like ChatGPT is considered a lousy model now, sometimes it will hallucinate. But if you use a stronger model like GPT-4 Turbo, GPT-4o, the chance of hallucination is quite good. The chance of hallucination is quite rare. Like it's close to zero hallucination. So it depends on what kind of model you use. So if you don't want hallucination, it's best to use a rule-based method to curate the output. Okay, but for now, this is the first version of the conversation class. Then we think through how to reply before drafting the reply. We do a chain of thought for this, like thoughts how to reply the user, then the reply itself, and then the summary of the conversation. I've tried removing these thoughts. The reply is not so good. So the thoughts really help the LM to think about how to reply and then reply the user. So this is the benefit of stuff like strict JSON, where you can use the JSON format to guide the output for the large language model. So then we append the summary, the conversation, and we then update the persistent memory as a separate call. So do note, this is a bit different from the last time I went through this. I have created a separate call for persistent memory so that we don't overload the cognitive abilities of the agent here. So the agent just needs to focus on generating the output for the conversation for the first part. The second part, the agent will then proceed to update the persistent memory with whatever is important right now. So you can see this leads to a generally better agent as well. Then we reply the user. Okay, any questions on this? I went through quite in detail about this class because this is the main class for today. We'll be using this class for 5 or 6 examples. So far, okay?
Yeah, just real quick. Out of curiosity, for the persistent memory, where you have that defined, is there a way to say you write out some hard-coded rule-based function somewhere and kind of just define that in the persistent memory? So basically, every conversation, when it runs persistent memory, it'll use that function, that rule-based function, and then output some kind of value that the LLM can use, like text or whatever.
Okay, so basically instead of asking the LM to update it using the LM itself, you ask it to update using a function.
Right.
Yes, I think that is possible. That's not currently implemented, but if we want to, we could have another variable here, like called like rule-based update or something, or like
Right.
deterministic update. Yeah, then when I see that you have a certain memory key that is linked to this, I can, instead of doing this function here, I can basically use that rule-based function that you created to update this persistent memory. I think
Yeah,
that can be
exactly.
done.
Yeah.
Right now I have put it outside of this class. So later you can see how this rule, maybe I just show you since you're interested in this. Like
Hmm.
the math Quizbot, I actually do rule-based processing here. And instead of having like using the LM to do this, so you see over here we have this persistent memory here, right?
Hmm.
Okay, so this is actually done by the LM. It's still done, but like stuff like current number of tries, like because every 3 tries, if the user answers incorrectly, I want it to shift to the next question. So I put this current tries outside of the chat. So because I don't think I'm going to abstract away this part here, like this chat itself, like I'm going to leave it free for the user to configure how you want to chat with the agent. You just need to call .chat to get a reply. You can do any rule-based processing outside of this .chat. Like you can do it here. And this basically will update some variables that are outside of the conversable agent, which can be rule-based.
Okay. Yeah, that's good enough for me. I mean, I don't need to be like catered to like in the class, but I just wanted to know if like you could implement it. But if you go ahead and you just put it on top of the chat, it'll go ahead and keep track of it. Okay.
Yeah, I think maybe that might be preferred than putting a rule-based function inside the class itself, because if you put a rule-based function in the class, it's quite limited how you can run that function. Whereas if
Hmm.
you put it outside of the chat itself, you can do whatever you want. It's more flexible.
Okay. Sounds good.
Yeah. So but by default, I'm catering for the general user, which probably doesn't need rule-based. Like the LM can
Sure.
update. Yeah. So, okay, let's just run through this. So I think this is Ray's favorite use case. So this is the psychology counselor. So this is revamped already. And this basically is to respond to the user's emotion and situation and respond in this preferred conversation style, which by talking to the user can be updated. So let's just do an example. So you want to try this, or I just type anything I want? Okay, maybe I start first. Like, okay. Okay, yeah, I just type, right? So maybe I just say like, oh, okay, because recently I've been like quite stressed to like complete my PhD as well. So let's try that. I'm stressed. Then let's see what the bot tells me. So it's like, there's actually a lot of people feeling stressed and stuff. And let's see whether it can respond to my needs. So it's like, I'm sorry that you're feeling stressed. We'd like to talk more about what's causing your stress. Yes, I've been trying to graduate from my PhD, but I still need one more paper. Right, let's see what's the. I understand the pressure you must be feeling while working towards your PhD. It's commendable that you've come this far, and I'm here to support you. Well done, yeah. If you you'd like to share more about the stress you're experiencing, feel free to talk about it. Okay, so you can see that as I talk to the bot itself, like the style is supportive and empathetic. The user is stressed, so it has detected that, and it's summarized that the user needs one more paper. That's not bad. I can say that yes, I am so busy with everything. I cannot seem to prioritize doing this paper. Yeah, which is true because like I don't really like to write papers. Here you're feeling overwhelmed, everything on your plate, like making it hard to prioritize is understandable. We like to stop more. Okay, so now maybe I don't really like it to ask me so many questions. I could just say, hey, maybe you just listen without asking questions. And then we see whether it understands. Like, feel free to share. Yeah, so it didn't ask the questions. So over here, it didn't update this preferred conversation style. So maybe you can just change the words to say like, hey, details of what the user wants. But I think it sort of understands that like it doesn't need to ask questions because it knows the past five conversation anyway. life is hard. Maybe we can just see whether they ask any questions. I hear you, life can be asked. I feel free to share. Yep. So you can see that it has changed the style by just by just this line here. Okay. Of course, we would prefer that this change to a more passive style. So maybe you can say, can you talk to me in a more passive way? And then we see that this is changed. This will change. And there you can see over here. So this has changed to passive. And what this tells me is that if you want to update persistent memory well, the words actually matter. Like what words you put over here matters because ChatGPT does pattern recognition and so on. And it matches based on semantic similarity. Okay, Ray says, I will also add what user wants. Okay, we can try that out. So if you are familiar with okay, what user wants, we can just change it to what user wants, right? How the user wants the conversation. So if you are familiar with strict JSON basically has a key and a value. So the key is what the persistent memory is, the key of the memory. Like you describe the key, like, okay, what user want, user emotion, and so on. The value here is basically the description of the key. So it's like what user wants, like how user wants this conversation. And you can even put like type string, type list, or type integer, if it's an integer, you can define all this here. This basically helps the LM better know how to generate your persistent memory. And you can see it's already generating here separately using a strict JSON call. So whatever you put in persistent memory is actually the output format of strict JSON. So just to show you, like if you look at the strict JSON GitHub, it is not updated yet. Yeah, the more updated is in TaskGen. I'm going to update this shortly. You can see like you have different output formats, like based on the key and the value. This persistent memory is exactly the same as strict JSON. It just tells the LM how to get your updated stuff. So you can do like in float string, list, in number, and so on. Yep. So the benefit of using strict JSON over stuff like Pydantic is that it's like at least 50% or less of the tokens of Pydantic because of the way I prompted this. All right. So you save a lot of tokens if you use strict JSON. All right. So this is the output format, and it is the same as this here. Let's try to see whether this works. So let's try another scenario, like I'm sad. All right. Why are you sad? Let me think of a reason. Sad. My dog died yesterday. All right. So let's see whether it's updated. So over here, it seems to be like, if you feel comfortable, we'd like to share more about your dog. Okay, so dog died yesterday. So this what user wants doesn't seem to capture. Okay, let me try to ask, like, can you ask less and listen more? There we go. So Ray, maybe this might work. Like, so you can see captured what the user wants for the conversation already. And yeah, you can like, can you tell me a joke each time I say the word sad? And you can see that like this, yeah, there we go. Here's a joke. I'm so sad. So let's try I'm so sad. And then see that the joke comes out. There we go. Yeah. So this is that's a great prompt, right? That's a great prompt. So this what user want is really capturing based on whatever we want the okay, maybe we just add to be over here, right? But it looks like this is great. Like just by modifying the words itself, you can change how this persistent memory is being captured. And let me just end this here and just show you, like, if let's say you want to see what your persistent memory is, okay, because we have wrapped this agent itself. So for agents, please feel free to go to the previous tutorials for TaskGen on how to define your agent. But like this, the agent name, and this the agent description, and this the LM that you customize. This is ChatGPT, but as of now. So if you want to get your persistent memory, you can go to my agent. Okay. Sorry, not my agent. Sorry, go to agent itself. And then you can go to shared variables. Remember, we have added 3 shared variables when we initialize the class. And the 3 shared variables are persistent memory, conversation, and I think what's the last one? The last one is summary of conversation. So you can see that if you want to like post-process the conversation, you can actually go and like take the conversation like that. And you can see this is the entire conversation itself. You can also like post-process your persistent memory in this format. So you can even take it one by one. You can say like what user wants, or maybe just take the summary of key incidents. And you can see this is the output. So you can do a lot of flexible processing of the output just by using shared variables. So I want to emphasize a lot and highlight that shared variables are very important because they store the state of the agent. And later you will see shared variables are the basis for global context. So global context is something that is really cool. It enables you to keep track of your agent's state, or your agent can also learn across tasks by storing the learnings in your shared variables and then referencing it using global context. So let me just, before I move on, I just show you like maybe how this would work for Llama. So I'm just using Llama 8B. So I just changed the LM to Llama, which is using this Llama over here from the Boto tree client. Of course, you need to put your, I believe it's AWS. Yeah, you need to put your keys over here for it to work. And this, let's use Llama and see how this works. So I'm just going to use Llama now and maybe ask it like, try a different one. I'm lonely. All right. I'm sorry to hear that you're feeling lonely. So actually, this is not bad. Llama 8B is actually is decent for generating JSON. Like you can ask like, my girlfriend dumped me yesterday. It's such a blow. Something like that. Yeah. So I'm so sorry to hear that your girlfriend dumped you. That must be an incredibly painful and a huge blow. It's okay to feel sad and overwhelmed right now. Well, not too bad. Not too bad. I mean, I think like if you are really feeling sad, this is consoling words. Can you not use the words sorry? Let's see whether Llama is good enough to understand this. Talk about this, requested to avoid. So they put in summary of key incidents instead of what user wants. I think that's fine as long as they track it. Okay, I'll make sure to avoid the word sorry. Why am I feeling sad now? Can ask and see whether like I'm so sorry, see whether it sounds like you're wondering why. Can you help me understand what's going through your mind and what you think might be contributing to these feelings? Also over here, you see the incident itself. Llama has kind of forgotten about this the girlfriend dump. But so what could be done is, instead of doing a summary, you could keep track using a list to add in these memories one by one. Or in fact, you could even do it as a rule-based method to append the memory one by one as you go through. So to do the rule-based method, you can just put your rule-based stuff here. Do rule-based appending here. Yeah, so you can keep track of the state at each point of time. It really depends on your use case. Yeah, I'm just saying that, like, if right now I do summary so that we don't explode the whole list. But if you make it a list and store it, I think that works fine too, as long as your list is not too long. Okay, I think that's a good enough like showcase of, oops, what happened? Okay, so that's a good enough showcase of like Llama. But you can also see Claude. Let's try it out just for fun. Like, hi, I'm sad. So based on my experience with Claude talks a lot. Like you look at this, Claude 3 Haiku talks like 5 lines. 1, 2, 3, 4, 5. Yeah, six lines. Like ChatGPT talks about 2 lines, 3 lines. Llama maybe 4 lines. Claude is super talkative. Yeah. So Yeah. So maybe we can ask Claude, like can you reply me only in one line? Till they understands what I'm saying. There we go. Actually, Claude, not bad. Yeah, not bad. Yeah, but it did not update it here. So yeah, you need to prompt it a bit better to based on your LM itself. The words matter a lot based on what kind of memory is being extracted. All right. So I'm here to listen and support you through this difficult time. Yes, I'm sad because my cat died yesterday. I'm so sorry to hear about the loss of your cat. I think it's doing well. So he is able to summarize this. And yeah, what I wanted to show with this is that, you can use different LMs as long as it's able to pass JSON out quite reliably. The conversable class, the agent class, all this should work. And I've made it work even better by decoupling this persistent memory update from the conversation reply. Because initially, if you lump both together, the chance of a JSON failure for the persistent memory is quite high especially since this is like a nested JSON once you put it inside here. Yeah, so by separating it like that, the reliability is much higher now. So feel free to try it and let me know how it works for you. Yeah, I tested it out quite extensively. It's working for me. So hopefully it can work for you also. All right. Let's move on to the next thing for today. So this is called the Sherlock Holmes short assistant. And I've created this in tutorial 5 back then to talk about shared memory and the global context. I've revamped this to use the conversable agent class, and let's see how it works. So first up, we give some example list of items that you can search for. Okay. Then we can also give a function to search through the memory to get the items by category. All right. So this is get related items by category. So notice that, for the functions, I have this thing called shared variables at the front, and this is intentional. This allows you to, based on the output of your function, update the shared variables dictionary directly, and hence give the agent the required context. So like over here, if we search for a certain item, we could put it into item search in the shared variables, right? And when we buy the item here, we can put I put in like a rule-based check to see whether the item ID is there. I put in also a rule-based check to check whether the money is enough to buy the item. I also put in a rule-based check to see whether, yes, I want to buy the item or not. So there's a few safeguards here to make sure that everything is correct. This is because LMs, if left on its own without the confirmation, might buy an item that you don't want, or it might buy an item without you having enough money. So stuff like this that requires a bit more strictness in the output, it's best to use like some code to do it. And it's best if you can just define it directly in the function itself without needing the LM to do those. Okay, stuff like math, absolutely horrible. Okay, don't use LMs for math. Okay, it might work 90% of the time, but the other 10% will just cause your whole use case to fail. All right, so use rules for this kind of stuff. And all these are wrapped nicely inside this function by item. So you can see that if the item is bought, we can say it's purchase successful. If not, you can say the user did not want to purchase. Right. So now to the shop assistant. So just define an agent called shop assistant. You are to assist the user in searching and purchasing items. Purchase item upon confirmation. Okay. And based on user input, give up to 3 choices from item search with their name and price. If user wants to purchase a specific items within item search, purchase it. Right. So this basically just prompts like the bot like when to do certain things. Okay, if you don't do like these 2 lines here, the bot may not respond to you in the required format. Right. So maybe one thing I can think of is that if you have a certain format of how you want the reply to be, maybe you can specify it inside the agent prompt itself. Or I'm even thinking that maybe I have another variable just to specify like output format for your conversation, because sometimes you want the agent to reply in a fixed structure. Yeah, right now we don't have that kind of structure, but maybe we could incorporate this. So yeah, I need y'all to help me test it out, see whether it works and what else you want to add it in. Then I can change this class accordingly. So this is still in the beta version. And your persona, you can even put inside the agent description. And let's see how it works. Okay, shared variables is basically what are the variables we want to like store as the agent state, purchase items, money remaining, item memory, which is the entire list of items that can be purchased. This should be actually a database. If you're using this for real, you can then do query over the database as part of your as part of the get related items by category. You can query your database, right? And item search is like what items that we have searched so far. Okay, we don't use the LM because we don't want the LM to hallucinate. Okay, so the agent does not have an LM as an action. Select subtask to be one because I realize sometimes if you give it more, it might just, search and buy the item straight away without confirming. So in this use case, we want a confirmation. So like we do as one. Okay, and next up, I want to show you this thing called global context. So global context is basically like if you have certain things you want the agent to know at any point of time, you can use global context to give that information. And it's best to give that information as part of shared variables. So you can see like over here, anything in this angle brackets, if the name is the same as the shared variables name here, it will use the shared variable. All right. So item search will go to this one. Purchase items would go to this one here. And then like conversation would go to the conversation thing that we have created as part of the class here. So it's like over here, we have this conversation. So it is very easy to use. Like you can just use global context like that. Of course, there's another way to do it. The other way is to use a function, which I don't recommend doing it right now because like I have created this just to avoid having to use the function. But if you really need to use the function, you can check out tutorial 5. And in tutorial 5 itself, there's this get global context function. You just copy and paste this one here. So you can also use a get global context function, and based on whatever your agent has, you can output the global context here and return this global context. So what this means is that you can manually add in the stuff that you want to do yourself here. You can do in your rules and everything. But if you could just use the angle brackets like that, you could just use global context. You don't have to use the function get global context. Okay, but both are actually added on to each other. I will just take the get global context output plus the global context output here for your overall global context. It's just that, if you use this get global context, you need to do something like that. Shop agent dot get global context. You need to do something like this. And, this is a little more troublesome compared to just doing this. So, if your global context can just be just a substitution of whatever you have in shared variables, just use this text method is much easier. This one is if you want more like configurability. All right. So I'm just going to delete this because I want to move away from using the function. I'm just keeping the function there for backwards compatibility. And also if you want more customizability, you can use the function. But I'm moving towards this global context string method because it's much easier to use. Right? So you put the global context, okay, as part of your agent. I mean, you could also define your global context here. Let me just show you. You could also define your global context here. And then we can just have one cell like that. So your shared variables is whatever variables you want to keep track in your agent. Your global context will just use those shared variables to prompt your agent. And you know what? Let's see how this works. So if you want the convo to start with something, you can put like a start convo and then just update the conversation itself. Okay, so this is like over here, my agent.conversation equals to start convo. Okay, this is useful because like later on, if you look at the code itself, oh, wait a minute. Oh, I might have done it wrongly. Okay, yeah, I'm supposed to update this one here. Yeah. So over here, there's no conversation here. Uh, okay, no worries. No worries. Yeah. I'll change this. So actually this doesn't matter at all because we did not up. So yeah, you could just like, if let's say you want the agent to like start with a certain, ask certain things, you can just print this out before we run the agent. So let's just try this. I'm your friendly shop assistant, Sherlock Holmes. How may I assist you today? So again, you want to type something, or you just let me demonstrate. I'm flexible both ways. Yeah, you want to try out the shop assistant?
You know what? I'm gonna ask for a car because I've spent so many hours asking my LLM for a car, and I've screenshotted the horrible answers I get
For what? Sorry, for car?
for a car. Yeah, because it's a while back, but like I would like screenshot all of the answers I got from my smaller LLM when I
Oh, you
asked
mean
for a
for
car.
this shop assistant case, is it?
Yeah, and it would break the logic because like it couldn't find the car for some reason when you did the search function. And it would just spit out blabberish answers that were illogical. It was funny.
Sure. Maybe you give me the prompt. I'll type it in now. We see whether it's better now.
Okay. I would like to buy a car.
Okay, let's try that. Oh, but the car is actually beyond your budget for this.
Exactly, and that breaks it. It just doesn't know how to figure it out.
Yeah, I see ChatGPT says that would you like to purchase? Right. So let's just try for fun, just say yes.
Okay, I want to see.
So yes, found the car here. So the output is
Uh,
unable to purchase
okay.
items, and the output over here is the car has been successfully purchased. So
I knew it. I knew it.
yeah. So this is you can ask like what have I bought so far?
Okay.
So you can see that as much as we want it to not hallucinate, the LM has successfully hallucinated, and there's nothing we can do to stop it from doing that. So
I know. Yeah.
this is the issue of like smaller models. Let's just try, if we instead of I mean we can also do like instead of LM here, we can do GPT-4o. I do have a Azure one, GPT-4o. We can do LM
Okay.
as GPT-4o. So actually moving onwards, I actually would like to not use this model thing much anymore. I like to
Hmm.
standardize the LM to this LM function itself because this would be usable for any kind of LM, not just OpenAI. This model is just for OpenAI. So I'm actually in the middle of revamping all the tutorials to use this LM variable instead. And I'm not going to depreciate this model, but I'm still going to keep it. It's just not going to be the default model of doing things anymore. The default is going to be LM. Yeah, this is just to standardize everything.
Nice. I like
So
it.
just to highlight this, I'm just trying to make this as friendly to use as possible. So I want people to know how to use their own custom LMs. That's why I'm making this the default. So let's try that again. I would like to buy a car. So search the car. Okay, not too bad. All right, so GPT-4o is a bit smarter. Like it far exceeds your current budget of 1,000. And let's just be a bit stubborn and say, I'd like to buy the car anyway. All right, and let's see whether it works. So over here, GPT-4o is a bit smarter. It says it's impossible to purchase it. Doesn't even go to buy it. My dear Watson, your determination is commendable. However, the car remains beyond your current budget of $1,000. So ChatGPT actually is not a very good model now. So GPT-4o works. Let's try Claude. Shall we try Claude to see whether it works? This Claude Haiku, the smallest one, all right? I would like to buy a car. Okay, so find the car. Okay, not too bad. It found the cars, and let's see what it recommends. Delightful. Here are a few options. We like to proceed with the purchase of the car. Yes, buy the car. Right. So you see, LMs are not great with math. So okay, here it failed to do it because like instead of saying the item ID is set the car price. All right, so plot itself failed because this item ID is not in the string output. Instead, it's giving like 9. So there's some issue with processing the JSON here. Let's try llama. So in order to cure these problems, actually, what you can do is instead of putting like stuff like item ID, you might name it separately, like saying item, no, actually item ID is fine. Yeah. It's just, in this case, like the LM confuses the numbers. Like it's so what happened to llama? Observation is not there. Observation is not in string input. This The user has expressed interest in buying a car, but no specific car has been mentioned. Okay, this is new. Okay, I never really faced an issue with this before. Let's try it.
Oh, have you really never ran into a llama issue?
Yeah, at least when I tried this yesterday, the it's able llama is able to run. Maybe 8B itself over here. What's wrong with this? Let me debug it quickly. Observation is not there. It's here, right? Observation is here.
Yeah, this is an issue I had a lot of when I tested out different LLMs. It'll do this exact delimiter on the key observation, whatever you're
I
using.
know why. It's missing the front bracket.
Yeah, it's usually
Yeah.
that. I was gonna
Uh,
say.
so actually Llama 3 is not that great with the strict JSON kind of output. Let's try Llama 3 70B to see whether it works. So this is something that I think it's very hard for me to solve because like unless I change strict JSON directly, if not this would be a problem. Let's try Llama 70B and see how. Or I could just rule base to add in the bracket for Llama. 70B works. Okay. So it's a matter of small LMs not being able to do that kind of formatting.
Yeah.
Okay. Invalid JSON format. Let's see what's happening here. What's wrong? Okay, so this is good because then I can find out what's wrong and I can improve it. Let's try again. Yeah, at least the car is running. Okay. So something went wrong with the string for the JSON format for the later on part. It's responding with nothing. Okay. And this is in response to this query here. Okay, that's weird. Okay, because it was working yesterday. I think maybe what happened was I changed the prompt a bit. Okay, but this is a great thing to highlight that in order to use the strict JSON thing, your LM must be able to interpret the JSON in the way like this. Like it must be able to interpret it like this. Yeah, so it must be able to respond it like that with this hex 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 thing. So if it's not able to do the hex 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 properly, it will break. So at least that's what happened with Llama. Okay, so yeah, unfortunate. I will go and figure out how to solve this. Hopefully, I can find an easy way to solve. But if not, maybe just use Claude or something. I I would like if I think Claude, at least Claude Haiku, it's not too bad in passing the JSON out. It's closer to OpenAI in some sense. In Llama itself, the JSON passing may not be that great. So you can see over here, this is the cost. Okay, let's not get the car because okay, let's try get me the car. That's good to break stuff. I think Llama itself, I'll figure out how to. Okay, so over here, this is the issue that Plot is facing. Look at that. They generated code. So yeah, very interesting. I'll go and figure out how to fix this. It seems that so far this is more or less catered to, okay, get me the bytes. So far, only OpenAI models can work pretty reliably for this, but the other models are not able to generate out this kind of thing. So let me go and figure out how to prompt it so that the other models can work as well. All right, so that's a good thing to highlight. And yeah, let's go back to like GPT-4. I'll try to fix the llama and the Claude one. I think it's fixable by prompting. So if I prompt the thing in such a way that the other models can work as well, then this would expand the TaskGen usability to other models also. Okay. So I think it just suffers because like for more complex prompts, it might lose the context more rapidly, at least for smaller models. So this is 4.0. Actually, let's not use 4.0. Let's just use normal GPT. So normal GPT is custom LM. All right, let's just use the normal one. Like I like to buy a car. So at least if you use something that is very close to OpenAI models, this whole TaskGen framework should work for you. Okay, so like over here, this car costs 100,000, which now it knows that it exceeds. Okay, skateboard then. You like to purchase the skateboard, press yes to proceed. Okay, I would like to buy the skateboard. And you can see this is the output of the function. Your remaining money is 970. Anything to drink or anything to eat, you can ask like, you can try something like hot day exit. Like see whether it knows that you want something to do with, it does seem quite hot today. How may I assist you further? So user made a casual comment on the weather. Yeah, so I think this is fine. Like you can ask like any drinks. And then we can see like, okay, oh, he search for items now. Drinks are not within my domain. So yeah, there's some issues with this kind of agentic thing with the smaller models, is that sometimes it might misinterpret your needs. You might need to search for drinks. And then outside the scope of my assistance. All right. Okay, so I think that's more or less it. Like obviously this one needs a bit more improvement. And I think this has already been is much better compared to like tutorial 5 already. Tutorial 5, in order to do the prompting, we needed to give a lot of things like address user as you, do not hallucinate. So this is for the agent reply. And for the purchasing agent, we actually also need to prompt like based on conversation, purchase based on this certain criteria. So last time I needed to do quite a lot of prompting to get it to work. Now all you need is this. So there's a lot of improvement already in that sense. Okay, but right now the issue that I'm seeing is that it only works well for 4.0, okay, which is not something I want it to work well for only. I kind of want it to work well with ChatGPT also. So I'll go and spend some time thinking about how to make this better. So yeah, stay tuned. All right. Next up, let's talk about the JARVIS system. So I just coded this up like about 5-10 minutes before the session. So in this JARVIS thing, like we are trying to mimic Iron Man's suit, all right? So like we maybe have certain thrusters, armor, you can check what's the health. Right now it's just random, right? We can fire some missiles also. So this one has a confirmation because we don't want to fire anyhow. Like we want to make sure that you approve it. So let's try it out. You are the JARVIS system meant to help Iron Man find out about the status of the suit and perform various miscellaneous tasks. I can request it for current status, check thruster and armor. So I gave it some hints here because like ideally, you should have a function called get current status that does all this like thruster, armor, all this all at one go. Okay, because like you don't actually need to check one by one by just doing it like that to see whether it works. If you have multiple steps, right? If there's anything in subtask completed, you already have performed these actions so that it doesn't do again. All right, let's see. The shared variables here are thruster health, armor health, missile count. The global context is just all this, right? Thruster, armor, and missile counts. So this is actually quite cool. Like I do like to get this kind of system because it's a more personal assistant kind with the capability to perform actions. So I'm just using ChatGPT here. if you want a very, very robust, reliable system, 4.0 is awesome. All right, 4.0 works very well in conversation class, but I'm trying to set the baseline a bit lower so that people can use open source LLMs. Of course, just now you saw Claude and what's that, Llama, when the prompt changed a bit because I changed the prompt just now, it failed to work. So there's this robustness issue right now. I'll try to fix it. We see what we can do about it. All right. Right now, let's use ChatGPT and see how it is. So let's say I want to do something like, what is my current status? And let's see whether it does the thing. Identify the equip functions to check. Okay, so it did not check anything because it already has this trusted health, armor health. Okay, I think that's fine. Check updated status. See whether it does the checks. So get trusted health 60. Okay. Now the trusted health is 60 and armor health is 100. Okay, so it only checks one. It didn't check the other one. Check updated truster. Yeah, so basically you can see this is something like to complete, the system needs to provide the inform the user about current trusted health being at 60. Okay, so over here, what you can see is that because we put in this global context here, it thinks this is the most updated ones. So what we can do is, instead of calling it get, we call it updates. All right. So this is like live coding. I'm just going to show you like how you name your function actually matters with how the LM interprets it. Update. What is my updated status? And you see that it links it to the updated functions. So you can see we update the trusted health. Okay, updated truster and armor health status. So over here, you can see that we want to update the truster and armor health status, but we only can call one. So this is an issue with the subtask identified here. We need it to only do for like, let's say if you only call this, you want your subtask to only be related to this. So previously, I actually have a way to do the updated subtask to make sure that this reflects what is called here, but I realized it's causing some JSON issues, so I removed it. So I think I'll probably add it back. Okay, so let me just show you, like, if we were to go to GPT 4.0, what is my status? Let's just try it. So GPT 4.0 is like much smarter. It can do all this automatically without you needing to do anything. All right, there's an enemy ahead. What should I do? Let's see whether it's smart enough. Yeah. Fire 2 enemies. Okay. All right, let's see what is the reply. Okay, so given your current status, recommend proceeding caution if 8 missiles ability available. Consider using them if the threat level is high. Uh, where am I right now? So right now, if you ask this kind of question, you can't answer because there's no function, there's no GPS here. The equip functions do not need. I currently do not have specific data. I recommend using the GPS or sensors to determine your location. So let's add in a GPS locator. So I'm just gonna get location. Or maybe you can just say update location and returns the users. Okay, and I'm just going to do like Singapore, US, India, China, Europe. I'm just going to give some return location, and we also update the shared variables. Okay, and this itself, we can put it inside here. And we can also put the location in the global context. Yeah, so I hope I've shown you like how easy it is to just add in one more function like that. So if we have the location as info here, we can use this to make decisions as well. And you can just equip the function called update location. And let's try our JARVIS system again. I have been tasked to protect Shu in headquarters in Singapore. Get me there. Right. So something like that, like let's see whether it's able to. So we call the update location, and location is confirmed to be in Europe. I understand. I recommend using a high-speed jet or contacting queue. So right now, it's only able to update location, right? But it's not able to go to location. So let's just give it a function to go to location. Travel to location. Then we put a shared variables here, and then we put like the location is string, and then the output is string, and then travels to location. Okay, and what we do is basically we just update the shared variables. Okay, so let's see. And then we can also put like return location. All right. So travels to locations. And we also can put another function here. Let's put like top up missiles to top up. Increases missiles by. Okay, so what we can do is we can just basically put shared variables. And then we can just return missiles topped up. Topped up missiles to top up. Current missile count is okay, something like this. So basically we give it the opportunity to top up its missiles and travel to location. So let's put it here. Yeah, being more and more like Iron Man, as you give it more and more functions, it should be able to be better and better at. Okay, so let's do now. I have an emergency situation in Europe. Get me there. So you can see that now it does a few travel to location is there now. So it's now traveled to Europe now and understood you are ready to proceed to Europe immediately. Actually, it's already at Europe. So this one might need to prompt it a bit better. So now the JARVIS system tells you, yeah, Europe, sure. There are 3 enemies ahead. Destroy them. Yeah. So if you can give it some combat module or what, then you can determine what enemy need what kind of missiles and so on. Then you can fire them and so on. This can be given as functions to this. So yes, let's fire 3 missiles and destroy them. So 7 missiles remaining. And let's see what JARVIS tells me now. Like understood, engaging missile now, proceeding with missile launch. So here I need to prompt it a bit better. Like it's actually supposed to be destroyed already. Like the enemy needs to be destroyed. But right now, we don't have any observation coming in to tell the LM saying that, hey, the enemies are destroyed. So the LM just thinks that the missiles have been fired, but nothing has been destroyed. So, like if you have an environment here, you could put in the environment and the LM would know this. So all this is GPT-4o. If you use ChatGPT, you're gonna get mixed responses. I think, Derek, that's why you have problems like with Llama and so on. It's because they don't really understand things that well. So it's very limited in the stuff you can perform with like the not so high-end language models. But if you use a high-end language model, it starts to look like an agent already. Like it looks pretty nice. Okay, let's try something else. You want to try something? Like these are the current actions. You can try something based on this. Like maybe that's right one. I've been hit. Check status report. Okay, but by right, if you know if the system is smart enough, if you are hit, it'll automatically tell you. So you update the trusted health, update armor health. Status of the suit has been checked and reported. Current status report. Trusted health at 76, armor health at 73, missile count at 7/10. All right. I see 10 more enemies ahead. What should I do? We're about to fire 7 missiles to engage the 10 enemies. Okay, so over here, because we didn't tell it how the combat works, it just just based on whatever we have and just fire it. And it topped up 10 missiles again. Oh, yeah. So it auto topped up now. Yeah. So right now, you see, because we don't have the environment feedback, is thinking that the enemies are not destroyed. Okay, so in order to to change this, what we can do is we can just put inside here all enemies destroyed. Okay, there are 10 enemies ahead. There are 15 enemies ahead. Each enemy needs 1 missile. What should I do? Right, so this is like a math puzzle now. So so top up 5 missiles. Okay, so I did not give a restriction to this function here. So it thinks that it can top up to, because this upon 10 is only shown over here. It's not given to the Jarvis itself. So okay, I guess I can accept this answer for now. Like, so we have 15 units top up, we have 0 missiles. Okay, you currently have 0 missile available, but you need 15 to engage the enemies. I recommend retreating to a safe location. So you see over here, there's some desync with the action to the comment here. So this part here, I'll need to fix it. But overall, you can see that the actions are based on the conversation, and it's actually pretty nice. Like, let's go back to ChatGPT and see how this performs. I have 7 enemies ahead, each needing 1 missile. Destroy them. Yeah. Okay, so sometimes it works, sometimes it doesn't. It's not that reliable yet. I just wanted to showcase like how this kind of Jarvis thing could work. We like to proceed with this mission. Yes, okay, let's see what it answers. Okay, so it fired the missiles again. Okay, we don't want that to happen. Okay. Okay. It still thinks that the enemies are there. So yeah, I think this is something that needs to be updated, because there's right now some desync with the actions and with the enemies, and that's because we don't have the environment feedback about whether there's enemies in front of me. So like, if you don't have this in the global context, so you can treat global context as something like, if you are a robot, what are the sensors that you are currently experiencing? Where's your location? What do you see in front of you? What's your robot status? Any obstacles? You can put everything in this global context. And to the LM itself, it will just use this to make your decisions. And that's what you see right now in this JARVIS system. It's just that we don't have the enemy count here. And that's why we are not able to, to understand that there's no, maybe if I change the prompt here, like no enemies remaining. Yeah. There's an enemy ahead. Fire. You're about to fire 10 missiles. Okay. I mean, here we didn't tell it how many missiles you can fire. I'm sorry, I do not have the ability to fire or control weapons. I recommend. Okay. So here, RLHF is playing a role here. Like, I do not. Okay. All right. Check status. Okay. So if you are using like ChatGPT, the status itself, it's not able to update it unless you know to update status. There you see, because of the stuff related to update, it's able to update it. So yeah, some limitations with ChatGPT compared to GPT 4.0. 4.0 is able to pattern match better. ChatGPT, you really need to be very, very specific with how you prompt it. Okay, so that's all for like the JARVIS thing. I actually didn't really test it out much before today. I just coded this like 5-10 minutes before the session. Any questions you have for this? Or good? They'll like this, because actually this is something that I really wanted to create for quite a long time. Yeah, and yeah, I think with a bit more tweaks, it should be able to do what the Iron Man suit is doing in the show, yeah, with enough functions equipped to it, with enough sensors. Right now, you see, it doesn't have enough sensors. You can treat the global context as your sensors, just put in more. All right. So next up, I'm just going to go through again like some simple stuff that, not really simple, but like some other stuff that we did in the past, and just show you the conversation bot is able to do stuff like this, like helpful math quiz bot. Though I do realize something, stuff that requires actions to be taken, the open source LM models are not that great with this function calling stuff. So I need to change the function calling prompt a bit. But if you don't have any like function calling stuff, you just need to do text-based output. Open source models actually work pretty well. Like over here, the helpful quiz bot, I tried plot and llama, it works also. Let's just try this out. So it's just a math question, and then based on whether or not, like I use a fixed processing method like straight JSON here to extract out the number, and then we do rule-based to compare to see whether is it the ground truth answer. Okay, so this is more helpful than asking LM to interpret the answer for themselves, because LMs are not good with math, right? So let's try this. Right now, the correct answer is generated by LM, but in the future, it could be like, instead of giving the question to LM to generate, you could randomize your numbers and add up, use a program to get the answer. So this current math question and correct answer for question, it could be a program. Okay, you could just code a program here to create a question here, and then just put it inside the agent's global context. Yeah, you don't have to use the agent to generate. So try to use as little LM as possible for math. All right, any paper that says I'm going to use LM to solve math, I don't think it's the correct approach, because LMs are really not great at math. The way the vectors work, it doesn't encapsulate the meaning of a number very well. So like here, are you ready for a fun math question? What is 2 plus 3? Maybe give the answer as 2. All right. Nope, incorrect. Maybe 3. Incorrect. 4. And then you see, in order to get it to, like, after 3 tries to repeat again, I realize LMs are also not that great with that. Maybe GPT 4.0 can do it, but not ChatGPT. So I had to do like a rule-based method to count the tries, and if it tries is 3, we just tell it like based on Oracle and what, like 3 tries up, reveal the correct answer, go to next question. So this Oracle itself, I basically tell it not to output it to the user, but this will help to guide the LM to perform better. So what is 4 plus 1? You can put 5. And yeah, you see, you got it right. What's 3 plus 2? The number of fingers in one hand, right? You can reply like that also. Oh, it didn't accept that. Okay. What is 3 plus 2? You can say like it's 10 divided by 2. Maybe like this would, oh, okay, it didn't extract it. Okay, but right, this, I wonder if they got it right or wrong. The input is incorrect. Okay, so over here, it only extracted out the number. Okay, it did not do the processing. So I think that's fine also, because like you really want the person to know the number itself, right? So can you ask harder questions? So if you ask generic stuff that doesn't have numbers in it, we won't add the tries. I adjust here's the next question. Do 2-digit addition instead. There we go. What's 23 plus 45? So the answer should be like 68. Okay, so I mean, this is just a showcase of how you can use LMs to do like math stuff. Not the best. Okay, I actually recommend against using LMs for math. It's better to use programs. But if you really need to use LMs to do math stuff, use a lot of rules as much as possible. This example here is just to showcase how you can do rule-based processing outside of your conversation interface. All right. Question so far for this? Okay, so actually the last one I've showed before, but I just want to show you again because I'm using a new format now. So escape room, I asked GPT create an escape room, and I just basically define an agent to run the escape room. You must output one of the available actions at each time step. If previous action fails, try another. Just a simple prompt like that. I give it the persistent memory, inventory, list of past actions, summary of past actions, list of rooms explored. So like we can even put stuff like, type list over here to tell it that it's a list. So you can run the escape room. This is the room state. You have a key lock portion. There's a lock door. What do you do? So pick up the key. And you realize the person that I'm talking to here is game. Okay, so that the LM has some context because I'm actually using this interaction with the world and the user as a conversation, right? And so the user is called game. And that's why by putting person is game, in the prompt for ConversableAgent, the agent knows that it's talking to the game, right? So that's by default, this is user, just to highlight, all right? So you picked up the key, all right? List of part. Okay, so array, sometimes it doesn't do that well, but it's able to solve itself. Pick up lock, unlock door, exit. Okay, so over here, the list of past actions is not working as intended. So let's not put the type list here and see what happens. So now we have pickup key. Exit. Okay, so pickup key, they unlock the door, it unlocked the door. Okay, but it did not update this with the unlock the door. So, this also shows that like this is not like updated properly sometimes for the language model. If we use like stuff like GPT-4o, I'm quite sure it will update better. So you can see that now the action is pickup key, unlock door. All right, so you can see that the actions that are outputted by GPT-4o is much more consistent, much more concise in that sense. And this is just a difference in the ability of the LM. Yeah, but I mean, as much as possible, I would like the agentic workflow to work with the lousiest LM possible. So I'll spend some effort trying to rejig some of the prompts. But if let's say you want to use this immediately for your use case, I think 4o is working quite well. GPT-4 Turbo, GPT-4o working quite well. Llama 3, not that great because it doesn't process some JSON correctly. Claude the higher models are working quite well also. So you can consider that. I think Google, I haven't tried Google, but I heard Gemma is quite good. So maybe it will work off the shelf as well. So you can see this is oh, this is ChatGPT. Nice. It has gotten the list of past actions. So yeah, stuff like this, you can see that this persistent memory is giving some idea of like what it has done so far. It's like keeping track of what has been done. Improvements to this is that instead of using LM to store this in persistent memory, maybe you could just over here you use some rule-based methods to add it inside your memory, and then in the agent itself you give it the global context to show like what are the past actions done. So that there are some ways to make it a bit more deterministic. And because right now, if you use persistent memory, the LM is going to update it by itself. And sometimes, it misses out stuff. But if you use rule-based methods to add it in, much like what we do here, like you use rule-based methods here, you are assured that it will work all the time. So these are some examples of like how to do different things. And yeah, I think I've come to the end for what I want to show today. Like, I do think there's still a bit of work needed for this conversation class, and but I want to just release it already because I think it's best to debug together. Like if you find any issues and what, not just feel free to put it in my Discord group or just let me know directly so that we can improve this to the form that even ChatGPT can do this JARVIS system. That's the end goal. All right. So I'm quite keen to make this very, very robust. And with that, like I think it's a good time to end this. Unless y'all have anything else you want to see, I can do some like live coding to show you how this conversation works. But the key conclusion for today is that you can just define your agent, define your description of your agent, like give it some actions, put it into a conversable agent, and you can talk to it, and the agent will do the actions for you, just like that. Yeah. So it's pretty simple. It's just like one step, define the agent. Second step, define your conversation agent. And last step, we just chat to the agent itself. So that's these three steps you can do chat. You can do chat with action calling, with actions to reply you. So yeah, that's more or less the showcase for today. Hope you all enjoyed it. All right. Yeah, that's all for today. I'll see you around. Okay, bye.